Good afternoon, and welcome to CabWriter 4 Beta 3. We just released the Beta 3, which has the new functionality for DXF optimization. And since we released a video in Beta 1 that covered the cut list optimization, I'm just going to go through some of the new features or the new optimization functionality in this video. It'll be a short video, but it'll update you on some of the things that have changed. So I'm going to start right off by doing what we did in the last video, which is create our production documentation. So I'll just go to the File menu, click on Create Production Documentation, say OK, and this is going to take a while. So what I'm going to do is set it up, go offline, come back when it's completed. But this is the normal setup. I'm using comma-separated files. I've chosen my door and draw report, cut list report, and DXF report scenes. And they happen to be the purchase part scene, the cut list scene, and the DXF scene. And I'm going to ask for draw fronts, draw boxes, door reports, and a spreadsheet compatible cut list. And if I want a DXF, a native DXF optimization, I have to choose both of these buttons. I can't choose just this or just this. I have to choose both if I want DXF. I'm not going to produce a cut list plus FX DXF. You've done that before and you know how that works. I'm just going to choose no cut list plus reports. And I'm going to start this. And I'll be back when it's finished. Okay, I'm back. Now this model that I'm working on, if you look up in the left-hand corner, is called Gracie Hopkins Kitchen Test File Skip. That's this file right here. And notice it's in my desktop. It's on my desktop. Well, what happened was there was a folder produced on my desktop called Gracie Hopkins Kitchen. Why not Gracie Hopkins Kitchen test file? Because it creates this folder based on the project name. And if I look at the project name, you'll see it's called Gracie Hopkins Kitchen. So that's the folder that it creates, the high-level folder that it places in the same place, in the same folder, in this case, my desktop folder, in the same place that the model is. So let's look at this folder and see what it's done for me. Okay, so it gave me the CSV file for the cut list, and it gave me the door and draw reports. So and it also produced a folder, this time named after the file name. So notice it's Gracie Hopkins Kitchen test file, whereas the parent folder was Gracie Hopkins Kitchen, named after the project name. So if I look in here, it produced a number of things. It produced the integrated DXF files. What are those? Well, there's one file for each material name and thickness. And inside of that is inside of that file is every single instance that is going to go on a 1/2 inch maple plywood pre-finished sheet. Notice it's just one file with all of the instances. The same for the 3/4 maple plywood pre-finished, and so on and so forth. These can be used to do optimization in something like Cut 2D Pro. The other thing we produce is individual files for each part, for each component actually. Each instance. Notice here, this is C1LB1 back 1 of 2, C1LB1 back 2. So this is a folder where each plywood thickness and type has all of the instances for that in there. So the one we're really interested in is the CW DXF files. In order to get DXF optimizations, you must have this. And this is simply every single instance in the whole model thrown into one folder. It doesn't matter what sheet it's going on. It's just every single instance in the whole model thrown in one folder. So there's 3 different types of ways we organize our DXF here. All right, so now that we've got all of that, we're going to come back to this folder again. But now let's go actually look at our optimization. All we have to do is go to File, Cut List Bridge, Sheet Optimization. And now in here, we have to set a few things up. We have to choose whether or not we want to rotate grainless sheet parts for optimization. In other words, if you're using something like MDF or something like that, which has no grain, you might give it the instruction to go ahead. It's okay to rotate any part at all, because on this material, if it's grainless, any material that's grainless, you're giving it permission to rotate parts. The default for that is yes. The other thing you can do, if you're going to paint your plywood, if it's plywood and it has grain and you're going to paint it, you can say ignore the grain. Now the default here is no, but you can choose yes and ignore the grain. CNC settings, edge margin. This is the margin all around the 4 edges of the sheet of plywood, where we know we're going to waste, in this case, whatever the edge margin is. And the default now, I changed it to 1/2 inch. The typical outside cutting bit is 3/8 of an inch. And so to avoid it going off the sheet, I changed this from 1/4 to 1/2, but you can change it to anything you want. The other thing is on the inside cuts. not inside cuts, but the outside cuts that are in the middle of the plywood, we want to make sure that when the bit is cutting one part and then it comes back and tries to cut the adjacent part, we don't want it to accidentally be changing even a small amount the size of the previous part that was cut. So we want a clearance added to the diameter of the cutting bit, and that's what this is. I made that 1/8 inch. And we can choose how we want to nest things. Now for CNC, you probably always want this set to optimum, but you can choose rip cuts or cross cuts. Those make more sense when you're doing panel cutting, as we explained in the previous video. And in that case, I'm choosing an edge margin of 1/4 inch. I don't have to worry about the blade or the cutting bit going off the edge here, so I can get a little bit more working plywood. So I set the edge margin here. The default is 1/4 inch. Saw kerf could be 1/8 inch or 3/32, and a clearance again of 1/8 inch. And again, I could choose optimum, which will give me the fewest number of sheets, or it can force all of the sheets to have their initial cuts be rip cuts, or force all of the sheets to have their initial cuts be cross cuts if you're on a panel saw. Now, the thing you want to remember here is for every piece of material, for every type of material you're going to use in your project, you have to make sure that it's available. For instance, I know I'm going to use maple plywood pre-finished in this project. And I know I'm going to use 1/2 inch material and 3/4 inch material, and I'm going to use plywood that's 48 inches by 96. So I have to set these up. And very important, make sure that the grain is set the way you want. If it has grain, you want to set this to yes, independent of what you set these. Don't worry about what you set these at the moment. Just make sure if it has grain, you say so here. And if it doesn't, if it's MDF, you can say no. And so as it goes through and optimizes things, it can then apply these to these settings. Okay, so let me go and check this again. I'm going to use maple plywood pre-finished. It does have grain. I've got two types I'm going to use. I'm going to use maple plywood. I'm not going to use 1/4 inch, but I am going to use 3/4 inch. I'm not going to use 60 by 120, but it's there anyway. Notice it has grain, and of course MDF does not have grain. Okay, so with all of that set up, I can now begin my optimization. And there we go. Now notice one difference between beta 3 and beta 1 is in beta 1 this come up blank and I had to choose something first before I got any results. I changed this now so it'll always come up with the first option first, or the first option here. It'll come up with that already shown, and I can go look at others. For instance, the maple plywood pre-finished 3/4. All right, so I've added a little something here. This will tell me the format. In other words, 3/4 inch thick, 48 inches by 96 inch sheets. This will tell me the name of the material. I can choose the labels here. Part number plus the description. Description only. Part number only. Subassembly. Not terribly useful, I don't think, but it's there. And I can also put the dimensions on there. And the way you read the dimension is anything in this direction means that's the length. This is the width, except for on rotated parts. These are rotated. So this means the length. This number here is the length, and this number's the width. That should be pretty obvious from looking at some of these parts. And I can put the info tag on there that tells me which parts have been oversized. This one's been oversized in width and length, this one only in width. If I choose a particular part, it highlights that part in the table. The other thing I've added here, by the way, is this first set of information right here. Because the optimization settings dialog box is closed, you may not remember what you chose. So it's telling you here, in this particular material has grain. You said you could rotate grainless stuff like MDF. You do not want to ignore grain if it has it. The edge margin is 1/4 inch, the saw kerf is 1/8, clearance 1/8, and the nesting direction is optimal. So that's just to remind you what settings you used to get this result. Now, when I print, I can print just the diagrams, these guys right here, just the cut list, those, or both. Of course, if I choose neither, I won't print either. So these are your printing options. And I'm just going to do a print preview here. I'll bring it on the screen. And this is how it'll print out. And I can scroll down and look at each of the individual sheets. And now this has to be open to print. So if I were to click print now, it wants to know what printer I want to print them on. Now, one of the things I can do is I can print them on a PDF and then email it to somebody or what have you. That's pretty helpful. Or I can print them on a colored printer or black and white printer. I'm not going to print right at the moment, so I'll cancel this. Okay, so now if I've looked at all of my sheets, this is the shop plywood, which you probably won't cut on a table saw this way because you're probably going to use scraps, but it's there anyway for in case you want to use new sheets to cut these out. That's the 1/2 inch maple plywood pre-finished. And there you go. So I think we've looked at all of them. So now I'm ready to look at the sheets that I put on the DXF scene. And I want to optimize those for the DXF machine. So all I have to do is hit close here or close up here. Either one will bring me to the DXF optimization if I did any. Now it may take a second, and there we go. Now at first glance it looks a lot like the other one. Well, that's only because these are just rectangles, there's no shape to them. These have a little shape and you see the shape. But if I were to go to the 3/4 inch maple plywood pre-finished, now you can see I've actually got the parts with the shape. And again, the parts in yellow are rotated parts. Now, you probably know what these little shapes are. This has tongue and groove, so that you're getting the tongue here. And then outside the tongue is where the shaper bit is going to follow. The line the shaper bit's going to follow to cut that out. have all the holes and everything on there. And by the way, if you have a piece of material like this is for the sink, so that the sink can sit inside the sink cabinet and not hit this stretcher. You'll get that kind of shape if you should put any pockets or holes or things like that in your pieces. Now, this is very much like the other one, just some slight differences. Again, I can click on any part, give me the line up here to look at. And I can choose my labels however I want them. The dimension and info checkboxes are disabled. Reason being, info doesn't make any sense since we're using the finished dimensions. Finished thickness, finished width, finished length for the DXF optimization, not the initial cuts like we do in the cutless optimization, not these numbers here. We use the final ones. So there's no need to worry about which ones have been oversized or not, because none of them have. And the dimensions don't make much sense because you're not going to be cutting these on a table saw or a panel saw, so you don't need to reference them. The CNC gets the dimensions from the DXF file, so no need to clutter up the drawing here with that. Again, we have this summarized settings. In this case, you'll notice slightly different. The edge margin is larger, 1/2 inch. The cutting bit diameter is placed here, and in this case, that's 3/8 of an inch, or that's the decimal diameter. And that's taken, by the way, if you look at the CNC setup, that's taken right here from the outside profile bit diameter, right there. That's where that's taken from. So that's the only other difference. Other than that, this is the same as the previous plot. You can print preview them just like before. And again, if you don't, if you want to print these out to take them to the CNC machines to give you a reference as to where to put labels and things like that, you can do that. And you probably don't need the cut list. So, these may be wasted sheets here. So you can choose to print out just the diagrams and not the cut list. And I'm not going to print them out. You've seen what that looks like before. So there you go. Now, so let's look at this folder one more time. Let's see what's happened now that we've done our optimizations. I still have these 2 files plus this folder, but now if I look in this folder, I have one more additional folder. This is called sheet folders. And for each, inside that, for each material type and name, for each material name and sheet size, and let me just move that over. For each material name and sheet size, 1/2 inch plywood, 48 by 96 sheets. Inside those, for instance, the 3/4 inch one, will be a DXF file for each sheet. So now this is organized by sheets. Now the interesting thing is I can take one of these sheets and I can open these in SketchUp. I'll show you what I mean. So if I just open SketchUp, a new SketchUp folder, and let me close this. I'm now going to open I'm going to go to my desktop. This is the Gracie Hopkins kit folder, Gracie Hopkins test file folder, the Sheets folder. I'm going to look at the 3/4 inch. Let me move this over so you can see it. The 3/4 inch maple plywood pre-finished. And I have a bunch of sheets in here. My mistake. I said file open. What I should have said is not file open, but import. Okay, now that's what I want. Notice that's the sheets folder, maple plywood, pre-finished, 3/4 inch, and I'll just look at, let's say, sheet 13. It tells me how many layers and circles and all that. Say close. So now, if I look at this from the top and get rid of the axes, I now have exactly the same diagram that we saw here for sheet 13. Let me go to sheet 13. There we are. And now let me go back to those. Should look very much alike. Now the nice thing about opening them up here is now I can use, well, let's see. Now I can use this to measure things. I may want to make sure that the edges are what they're supposed to be. 1/2 inch, that's right. And the bottom, or the left edge. Now this is the line where the bit is going to follow, but this is the end of the tongue of the part. Notice that's 1/2 inch. And notice now that the bit, the center of the bit is here, and it won't go off the edge because it's got 1/4 inch when all it needs is 3/16. Okay, so but I can measure parts too. So you can actually use SketchUp to make sure everything's positioned properly, and you should. You need some kind of method for actually measuring. You can't do that in these drawings. There's no capability right now to measure things in these drawings. Okay, so with that, I think we're done with this video. And until Beta 4, have a good day.